So we've built the layout, we've got the track laid, the scenics in, and we're looking to add even more realism to the layout. So we can add movement, that's covered another time, animations, crossing gates, that kind of thing. We can add lighting effects, very useful to give ambience. And we can add sound effects, which is what we're talking about today. Start off looking at some of the commercial opportunities. They come either single sound players or multiple sound players. The first one we're looking at here is the Gauge Master. Plays a single sound, the fire engine siren. Connect your 12 volts in your speaker, trigger it, and it plays one single track for a hefty £46. Tracks do a steam whistle module. You connect your 12 volts, you trigger it either with a push button or with a magnet and reed switch, and it plays a steam whistle sound. Again for £24.50, not a cheap price. But you can buy more complex modules that will play multiple sounds. For example, the SS600 costs £176, but it does play 15 different sounds. It comes preloaded with one card for one set of sounds, but if you want to have, say, a mixed layout of steam and diesel, you'd have to buy the extra card, another £35. So you're talking about over £200 for this one, just to get local sounds. Gauge Masters sell the Kato Soundbox, which has got 6 different push buttons for sound. It's got a built-in speaker which isn't not as handy as it sounds, because if you've got a layout and your object you want to have the sound coming from is 10 feet away on your layout, you don't want the sound to be coming from under your chin. You can of course add an external amplifier, but that's extra cost. And they also work with plug-in cartridges, as you'll see in a minute. The one benefit of this particular system is it covers back EMF. In other words, if you've got, say, a steam loco chuffing along, you can sense the current being taken, and if it changes, it can change the chuff rate coming out of the speaker. There's the range of sound cards that are available for plug-in, and they're 30 odd quid each. So again, not a cheap option. But if you think that's dear, look at the Soundtracks. Soundtracks do a module that can handle 6 different distributed speakers on your layout. It can handle cross-phase between 2. So if you get 2 speakers, you can make the sound diminish at one end, increase at the other end, and you get a panning effect. Of course, that requires that you have some way of knowing where the loco is, so you have to buy occupancy detector for another £111. So you're talking the best part of what, £630 for this system. Good quality, but only plays local sounds. So you're not going to get station announcements or farmyard sounds or factory sounds or whatever. So that leaves us to the question, are there some alternatives that we can buy or build? And the answer of course is yes. Start off with the least useful, and we'll build up later. For £3.50 on eBay you can buy a greetings card module. You record the sound yourself in that little microphone, built-in speaker, built-in batteries, so it works straight out the box. You record your message, and then when Granny opens her card, it'll say Happy Birthday Granny or Merry Christmas Granny, whatever the happens to be. Not great quality. For £2.62 you can adapt an MP3 player. You take it out its case, add on a 5V regulator and a switch, and off it goes, and it'll play one sound from that SD card, and that sound can be as long as you like depending on the capacity of the SD card itself. And then there's the ISD 1820, again with a built-in microphone, so the quality isn't the best. You have to have a 5V regulator because it only runs on 5 volts, not 12. Built-in amplifier, so you just add on a speaker. And it's got a limit of only 10 seconds of audio. It can work in single pass, which means press the button and it plays the track once through to the end. Or jog just means it'll replay, it'll loop in other words. That's the instructions for it. One benefit of that is you can buy the kit, record the sound, take the chip out of the bigger board, pop it into a little bit of Euro board with an opto isolator, and you've got yourself limited function sound decoder add-on. In other words, you take the output from one of your decoders, put it through an opto isolator, it'll trigger the sound player, and the sound player is powered from the DCC itself via this circuit here. That's it, working. I tried it to check it worked. Yep. Let's take a moment to consider audio file sizes, because the sound players either have built-in memory for storage or they use a micro SD card to store the audio files. If you've got a player with an SD card, then it's less of a problem because you can have high capacity SD cards. But if the memory is built into the board itself, then that has limitations on what the file sizes can be. A couple of years ago on our website we had links to websites that provided various sound effects that were suitable for model railways, and the YouTube Studio contains an audio library of downloadable music clips and sound effects. Problems are that most of these are either stereo and in high quality, whereas in most model railways we don't need stereo effects, and the hi-fi is less of an issue. So how do we get around problems of reducing file sizes? So let's have a look. What we have here is meant to be part of an audio track that varies with time, so the amplitude of the signals going up and down as I speak. And what we want to do is turn that analog voice into a digital representation. So there's two factors we want to look at. The dynamic range and the sampling rate, they both affect the quality of a clip and also its file size. So let's have a look at it. What we have here is the audio clip being sampled over time, and we can sample it at these intervals or much shorter intervals. So clearly the more often you sample it, the more accurate representation it will be at the price of storage, because if you sample it 4 or 10 times more often, it'll take 4 or 10 times the amount of storage space. So, and on the other axis here, the amplitude, clearly if you only sample it roughly compared to finely, then the result is not so good quality, but of course takes up less space. Let's have an example. So what we have here is the black line represents the audio itself, and if we have a low sampling rate, if we only sample every so often, then what happens is we sample at that point and it stays at that level till the next sample, and then it's sampled again here, stays at that level again till the next sample. So you can see big irregularities. There's whole times here where there's been large changes that's not represented, and then there's large falls in the amplitude where the DC level remains high. So a low sampling rate reduces the file size, but we've lost quite a lot of the audio detail. If we've got a higher sampling rate, if we keep checking the amplitude more often, then it more accurately represents the audio. As you can see there, the missing parts are minimized, but at the expense of sampling of what, 3 times the rate. So that covers how often you sample. That has an effect on the quality and the file size, but the dynamic range also affects file size. We can sample at 8-bit, in other words, we're only converting an audio file into 256 possible levels, and that's commonly used for voice, telephone and so on. 16-bit gives us 65,000 possible amplitude levels, and that's what CD uses. And for all the real hi-fi, 24-bit is used. You can see there, CD samples at 44,000 samples every second. If we then do a calculation, if we sample at 44,000 samples a second, and every sample can be up to 16 bits, in other words 2 bytes, then stereo is going to take up 176k for every second of audio. So you can see how quickly you're going to fill up your SD card or the storage on your sound player. And that's why we end up having to use compression rather than the raw audio samples. Commonly MP3, but as you'll see, OGG is now a good contender in that field. So what we want to do is take those tracks and reduce it from stereo to audio, reduce the sampling rate and the bit rate. How do we do it? Well, we can use this piece of software here called Audacity, free to download, and as you'll see in a moment, very easy to use. Along here we have the information about the file. It's in stereo. It's sampled at 44,000 samples a second, and it's sampled at 32-bit rate. So how do we then do the conversion? Let's have a look at the process. We'll use the first file here, a 1-minute piece of music called Drifting. We'll open up the Audacity application program. We'll load in that audio track. You'll see here 32-bit, 44 kilohertz, and of course it's in stereo. The first job then is we'll resample at, say, 22 kilohertz. We can then change the format to 16-bit. We can then mix the two tracks down to one single mono track, and we can export that as an OGG file, and we'll call it drifting.ogg. Happy with that. And the file has shrunk from 1.1 meg to 438K. I'll now play the original file and the processed file. Here's the original at 1.2 megabytes. And here's the processed file. Could you detect any appreciable difference in quality? Probably not. But to be honest, I cheated a little because I didn't play you the one that was down at 22 kilohertz. I processed it down to 8 kilohertz. So the first track you heard was 1.2 megs. The second audio track you heard was actually only 251K. So we got an appreciable reduction in size with no appreciable reduction in quality. As you see, we can make appreciable file savings. I did some more. Let's have a look. And down the bottom you'll see that the file we just did, if we make it a mono only, it dropped to only 37% of its previous storage. If we make it an OGG file, it's now 1/5 of its original size. But I did some more sound effects rather than music, and they're even more impressive. That the ice cream van, you probably heard that operating on our layout at the school, is now down to only 2% of its original size. So it's dropped from 3 meg, which is huge, to only 75K. And the same with the Mind the Gap audio track. So large savings going on there. If you don't want to download and use Audacity as a software, there are online converters, one-offs. If you only get one file to convert, it's fine. You can just drag and drop onto the website page and it'll convert it for you. You can then download that same file as an OGG file from their website. You can see you've got options what to change it to. We're going to convert to OGG and drop in an MP3, sometimes a WAV. So you can choose what format to do its OGG, and then you can change the various rates if you wish. Let's turn now to 3 multi-sound players that are both adaptable and reasonably priced. Starting with the one we've covered some time ago, the DF player. As you can see, the current price on eBay is only £2.32. It requires a micro SD card onto that price, of course. Its advantages is it plays WAV and MP3 files. It covers a whole range of sampling rates, can handle them all. If you want to use it as an MP3 player only, then it can handle 24-bit output, digital to analog conversion output. So it's got high quality output with a little built-in 3-watt amplifier, which is very handy. It's also very small. As you can see there, it's only 20mm by 20mm. So it's got these things going for it, but on the other hand, certain disadvantages. It uses 5 volts or a 3.3 volt supply. So you have to have some voltage regulator to handle it. But more importantly, you'll see I've got an RX and TX marked up there. You have to pick your audio tracks by sending a serial signal into the RX to say play track 5, play track 3 or whatever. So that involves some controlling hardware and software that you program yourself. It does have what's called a ladder mode, which is a whole collection of resistors all in series, and you can tap off them. But that's used for MP3 control, speed up, next track, stop, start, pause, volume up, volume down and so on. It's not really what we would be looking for in our model railway locations. The March 2017 journal had an article that I wrote about how to build and program the Arduino based version on a piece of Vero board. Since then we ordered up locally, I think it was about 30 PCB versions, and I'll show you one in operation a little bit later. So you'll see on the Vero board version down the left hand side we've got, and some on the right, various pins that are the input pins to play tracks. So you hit pin 5, you'll play track 5, you hit pin 9, you'll play track 9, and so on. And then you'll see wires going between the Arduino Nano to the player to tell it to play various tracks. Fairly simple, that's the circuit for it. The push buttons or track detectors or anything that will bring the input levels down to 0 will trigger, and then it'll send messages to the DF player to play that appropriate track. And that was our equivalent of the one I showed you earlier, this SS600, which cost 176 quid for local sounds only. This inside has just got the board I showed you a moment ago. That board there sits inside this box with the external volume control, selection of buttons and the legends up the top saying what they do. And you can pick your own soundtracks. It could be local related, or it could be station related, or factory or farm, any sound effect you want. And you press the appropriate button and it plays it through the internal speaker. That's the low cost but same quality of the SS600. Let's just have a listen to it in practice. So here it is, built into the case with the push buttons and the legends up the top, volume control, speaker. Press a button, plays the sound. 18 possible choices here. For all kinds of background sounds. In that example, we had the DF player inside a dedicated case with speaker and amplifier all in the one unit. In practice on the layout, it's unlikely you'll have it that way. You may have some buttons on your control panel to play sounds, but you may have also sounds triggered from train detectors and so on. So it's much more likely that the module will be sitting somewhere under your baseboard. So we can trigger it from various sources. Here's an example. It could be from push buttons, it could be from switches, all kinds of switches. It could be from reed switches. It could be controlled from other modules. The outputs from an EasyBus output module, from a DCC decoder outputs, from C-bus outputs and so on. So there's a variety of ways in which we can actually trigger the sounds. Here's an example of a push button on the left, but on the right, instead of having one button for every sound, we can have a rotary switch. Pick the sound you want and then you press the button and it will play that particular sound. Let's have a look in practice. This is the DF player showing various possible inputs from simple push buttons to a rotary switch to choose your selection and a single push button. Or here, I've got a reed switch. And this reed switch can be activated by a magnet passing by it. Or any device that brings down one of these pins to 0 volts. I want to look now at other ways of triggering not just this particular DF player but the other two modules I'm about to look at. So one of them is using RFID. As you can see, it was written as a journal article some years ago, but essentially we've got a tag reader. You can see it there in light green with its own coil, and when you pass a tag over the reader, its ID is read in and is then sent to the Nano. Nano reads that particular pattern and knows that means to play track 3 or track 5 or whatever. So it's serial. The Nano in this case doesn't have multiple input pins, it's just using its serial input. So it's serial between the reader and the Nano, and of course serial again between the Nano and the player, passing commands back and forward. Very handy. It means you can have locos fitted with their own tags, and when the train comes into the station, that particular tag is read and you get a station announcement specific to that loco. The 10:15 from Clapham has arrived, etc. The code is also written, by the way, that if the train stays on the platform, in other words the tag remains over the reader, The announcement won't repeat ad infinitum till the train leaves. The code is written such that it will wait, it'll play the track once, and it'll wait until a different tag comes along. So that's very specific, but very targeted and useful. A simpler one, again I put in the journal, is to use a little fob, transmitters, receivers you can buy on eBay. 4 buttons, you press button A, then the receiver's output A goes low, changes state. Press button B, the receiver's pin B changes state, and you just feed those changes of state into the Nano, and in that way you can play 4 different tracks depending which fob button you press. And then I did one to repurpose an old discarded Sky remote with hardly any. It's a radio, infrared. It's an infrared transmission picked up by an infrared receiver, and that's the only hardware you need apart from the remote. It's all in the software. Again, you hit the Sky button, it sends out a particular pattern that's appropriate to the key you've pressed. The Nano understands that pattern to mean play track 1 or track 2 or track 3. So that's a range of different inputs rather than just push buttons and switches. The next module I want to look at is the one from Adafruit or Adafruit, a well-known supplier of components and modules. Not the cheapest, but very well supported in terms of tutorials and source code. So let's look at their new Audio FX soundboard. This is the FX soundboard. You'll see right away it doesn't have an MP3 option. It either plays WAV files or OGG files, as we covered earlier. So if you've downloaded an MP3, you'd have to convert it to WAV or OGG. A little bit more than that shortly. The board itself is about the size of an Arduino Nano. You'll see it in operation a little bit later. They sell 4 versions depending on how much money you want to spend. Some come with only 2 megabyte of storage, others come with 16 megabyte. Some come with an audio output only, you have to provide your own amplifier, and some come with a built-in amplifier. So you pay your money, you take your choice. It runs from a 5 volt power supply, so once again you'd have to have your own voltage regulator to get it from your 12 volt bus. It's got 11 digital inputs, so you can play 11 different tracks just based on push buttons or switches or totties or whatever. Or alternatively, you have the option to have serial input once again. So you can control it from a Nano or RFID, all that stuff we discussed earlier. This particular one I'm showing you has got the built-in amplifier, and that's your 2 speaker connections, your left and right channels. It also has an option up here to have audio out to take to a separate amplifier. The cheaper version doesn't have this. You'll see it later. It's got a headphone socket here and a separate audio out to take to an amplifier. There's no micro SD card, of course, so the 2 megabytes we're talking about and the 16 megabytes are the storage capabilities of this module. So we have to load in our WAV files or our OGG files via the USB as if it was a memory stick. The documentation says you can play up to CD quality, 44 kilohertz, remember, and 16-bit. But at that rate, that bit rate, remember, was 175 kilobits per second. At that rate, the 2 megabyte option would hold only 12 seconds of tracks. And even the 16 megabyte version would hold only 90 seconds. If you went to mono, of course, you're going to more or less double it. If you half the bit rate, again, you're going to improve it, double it again. Or if you go right down to 11 kilohertz, you can get 90 seconds. Doesn't sound very much, but remember, if it's just going to be a horn blow, a steam train whistle, a short station announcement and so on, they don't take up much time. You'll get quite a lot even in 90 seconds. However, it also supports the OGG format, or more specifically the OGG Vorbis format. And you saw earlier that can give you much better compression rates. So we want to, if possible, use that, and all of a sudden our 90 seconds or 12 seconds at the top here could become 2 minutes with even at the cheapest option. So 2 options. You can have a WAV file. The data is uncompressed, so you get very high quality. You also get very large files. The good point about the WAV files is if you wanted to have, say, a background ambience track. So the one section of audio will play over and over again. It will loop round to itself. Then the WAV file will play instantly because it's uncompressed. The OGG Vorbis, much smaller files, still give you good quality, but the fact that it's been compressed means it takes time to start the decompression. It's only 50 milliseconds, but enough to be detectable in a loop situation. You probably wouldn't notice it just playing a single track. But if that track loops, it's going to play, little hiccup, play it again, little hiccup, play it again. So you take your options. You can mix them on the same board. You can have some WAV and some OGG. So let's look at how we handle files with the Adafruit option. There's one plus point with this particular module. You don't require to set lots of little dip switches or controls to get different effects. The effects are switched by how you send the command. So, and that depends on what you've named the track itself. In this case, the basic option is to have the letter T followed by a number 000102 and so on, .ogg, or if it's a WAV file, .wav. My examples will all just use OGG. So if you put in T00 and then you bring down the 0 pin, it will play track 0. And it will play it all the way through till the end. The downside to this whole system is that it's pulse operated. In other words, if you threw a switch to play the track, it'll keep on playing it forever, it'll just keep on looping. You'd have to pulse a pin to get to play a track to the end. But that's flexible. Plays one press, plays one track. if you use the hold option, that's just T and then the track number 0001, etc., with the letter hold after it, and that means it'll only play the track as long as you hold the button down. So it won't play it to the end with a single pulse. You've got to hold it down, and as long as you hold it down, it'll play the track and loop if you want it to. Third option is the word latch, track 0001, latch. One press to start it, one press to stop. So it all depends on your options, like wheel squeal. One pulse from a totty as the train comes into a narrow bend, and you'll play the wheel squeal sound until you hit the second totty, and that's a second pulse to trigger it off. That kind of option. Another option is to have the word next. And it'll play one button is all required now to play up to 10 tracks. It'll play them in order. So if you've started with track 01. So if you started with track 01, then it'll play 2 the next time you push that same button. It'll play track 3 the next time you push that same button. It'll work its way through in the order of the track numbers. However many you've put in, it doesn't have to be the whole 10. And finally, the other option is to have random, which is very useful. So when you press the button, it'll play a random track, up to 10 different sounds. So it's ideal. As you see at the bottom, I've got a suggestion that if you put a timer into one of the inputs of this Adafruit module, and every time the timer gives you a pulse, it'll play one track at random. So if you've got a farmyard, it'll play the cows, and then it'll play the sheep, then it'll play the hens, then it'll play the farmer, then it'll play the tractor, or in any order. Never the same one, you know. And again, if you want to have sounds in a factory, all that kind of stuff. So you have the option to play a single track to the end, right through to playing multiple tracks, through to playing random tracks. So it's very flexible in how it handles its operations, and it's all controlled by the expression you give or don't give at the end of the track number, how it performs. So there's the interconnection between the Adafruit board and the Nano. Only 3 communication wires. Of course, they share the same ground wire. For those who are Arduino coders, that's a very basic setup. They're going to have serial communication. You're going to talk to that soundboard, set up which pins are going to be connected to together, and then after that it's simple to say SFX, which is the board description, play track 1, play track 5, and so on. So it's very, very simple to code after you've done your basic setup. And then when you go into the serial monitor of the Nano, that's what you'll see, and it gives you the options to play different files and so on. Let's have a look. Here's my setup. This is the Adafruit player switched into serial mode, and a serial connection between the Nano and the player with these wires here, and then the Nano's communicating with my computer via the USB. Now we need a serial communication program. My preference is putty. We want to use it in serial mode, and we have to tell it what COM port we're on and what speed we're communicating at. Hit open, and the message you're seeing is coming back from the Nano. If I want to, I can hit the L key. You'll see here a list of the files that are in Adafruit's memory and their size. Now if I want to play one, I hit the hash key. It'll ask me what track, track 4 say, hit the enter key. Or hit key 1. And finally, the last of the three modules. It's the DY SV5W, available for £3.41 on AliExpress and eBay, etc. Let's have a look. The module uses an SD card to store the files. You load them in via the micro USB port here. It's got a built-in amplifier for 5 watts. You just connect your speaker here, or the option to have audio output to headphones or to a separate amplifier. Volume control sets the volume coming out of both of these. Again, 5 volts for power, so you have to have a voltage regulator. And you have a series of pins here, 8 different pins to play 8 different tracks in that particular mode. And you have a selection of dip switches depending on what you want to do. Once again, those input pins can be push buttons, switches, modules, totties, etc. This module sets up its modes using dip switches, and one combination will turn it into a standard MP3 player. Another combination will set it up as for serial programming. But there's 4 modes that we would probably most likely use for model railways. And this is the first one, called I/O Mode 0, standalone mode 0. It matches 8 inputs to 8 tracks. So if you take pin 5 down to 0 volts, it'll play track 5 and so on. So there's a direct combination between input pins and audio tracks. Again, you can pulse it with a push button or flick a switch. This time, unlike the previous module, it will play the track through to the end and stop. If you keep the switch down or the push button down, when it gets to the end of the track, it will repeat. In other words, it will loop. Let's see what that looks like. This is the built module. It's in standalone mode 0, i.e. one pin plays one track. If I hit a pin, it plays the track all the way through. If I hit a pin and then hit another pin, it'll interrupt the track and play the second one.
Need input. Need input.
If I maintain 0 on the pin, it loops. A variation on that mode is I/O standalone mode 1. Works in a very similar way, matches 8 to 8, but this time it only plays the track as long as you keep the switch or the push button down. And that's the only difference between mode 1 and mode 0. There's also this interesting mode called the combination mode. It doesn't map one pin to one audio track. Instead, the module reads the entire 8 inputs as one byte coming in, as a binary pattern. So if you have a PIC chip or an Arduino chip that can write out a byte at a time onto 8 pins, it can read that binary pattern and play the appropriate track depending on the number. So if the binary pattern goes from all zeros to all ones, that gives you 256 variations. So it can play 256 tracks. Once again, this mode plays it through to the end. Well, the mode 1 version of it only plays it as long as you hold the binary pattern on the input module. Well, we've covered a range of modules of different prices and abilities. I hope you'll agree that they all offer the opportunity to add extra life and ambience to your layout. So it's only time now for questions, comments, and any suggestions that you guys may have. Thanks.